Hi, this is our Nolan Creek project. I'm Collin.
I'm Logan.
I'm Isaac.
And I'm Andrew.
So the driving question for our project was if Nolan Creek was the only source of water for Belton and each person needed 250 cubic feet of water per day for use and consumption, how many people could live in Belton?
So here's a few pictures from when we collected the data at Nolan Creek. And here's what we used to do it. We had a 25-foot rope marked every 6 inches, 2 metal stakes, a hammer, meter stick, something to record with, a towel, change of clothes, and a stick.
Our procedure was to first stretch the rope across the creek and stake the ends down. Second step was to measure the depth every 6 inches with a meter stick and record the data. Third step, make note of the creek body we're collecting to see if it was smooth or rough. Fourth step, measure 25 feet downstream and record the time for an object to flow down the creek. We did this 3 times to find an average. Step 5, laugh at Colin's cold legs.
Oh, very fun. So now that we had our data points, we plugged them into Logger Pro to get 3 regression lines to find the equations we could use for our integrals. We typed these into Desmos to make our full graph, as you see on the right, and to find our definite integral. To convert from square inches to square feet, we divided our values we had in square inches by 144 to get to 1 square foot.
So first we took a right-hand Riemann sum, which is where you take the right bound of each of the values, and once we plugged them into the calculator and got the y values at the right points, we got our right Riemann sum value to be 105.288 square feet.
So next we took the left-hand Riemann sum, which is doing basically the same thing as the right, but using the y values on the left side. And for our value there, we got 105.256 square feet.
We then took the midpoint Riemann sum, where you take the middle of each section as your y values instead of from the right or left section of each 6-inch increment. The midpoint Riemann sum came out to be 107.091 square feet.
We then took the trapezoidal Riemann sum by using the trapezoid formula, which means we took the y value for the right and left side of each section and averaged them together and then multiplied by the height. We got our value to be 105.27 square feet.
The definite integral was what we used to find the exact area. We took the integral using Logger Pro values that we found and our calculators to get the exact definite integral, which gave us our exact area, which was 111.775 square feet.
We then had to determine our friction correction factor. Since we had a pretty smooth concrete base at our subsection of the creek, we used a larger coefficient of 0.9.
For linear velocity, this is where we use the time for a thing to go down the creek. We measured 3 different trials with 3 different sticks to find the time it took them to move 25 feet down the creek, and we found a rate of the volume of water going down the creek to be on average 101.61 cubic feet per second. So we multiplied that by 60 to get our minute time, and then times 60 again to get 365,797.2 cubic feet per hour, and we multiplied that by 24 to get 8,779,132 cubic feet per day, and then we multiplied that by 7 to get 61,453,929.6 cubic feet per week.
Because each person needs approximately 250 cubic feet of water per day, and according to our measurements of the flow rate in the area, we determined that 33,302 people could be supported by the water in the creek.
So in conclusion, after figuring out that Nolan Creek could sustain 33,302 people, we could come to the conclusion that Nolan Creek can in fact support the population of Belton, because that number is 21,734. And to find the exact number of Beltons it could support, we took that number and divided it by the population of Belton and found that it could support exactly 1.5323 Beltons. So although the closest estimation to the actual area was the definite integral, the best estimation we would use would be the left-hand Riemann sum, because it's an underestimation of the area, which allows for some breathing room.
Yay.
My legs are cold.
That's all, ducks.